Now, the second part of the lesson is try to connect the differential equation to algebra. From the example you observed above, you can guess. You say, if I have n variables x, and that function is pretty much look like this, does it? Times a vector v. Now, look one more time. See, that's r equal to ERT times this vector, which is a constant. This r equal -1 times this r equal -1. So it's always look like this. Then you can guess, how about if I have this solution, I try to solve this problem. That's homogeneous. And you plug it in. The left is going to be e to the RT times v. Take the derivative to t. That is a constant. You never mind. That's what you get. Because the derivative ERT, take a derivative by chain rule, is RERT. That's the only thing. That's the left hand. Let me erase this. And the right hand is this A times the X, A times e to the RT times V. That's the right hand. That should equal, right? So the left hand equal that. The right hand is this. What about e to the RT? For any matrix, I cannot change the order here, but that's a constant. I can take it out. Then I have e to the RT, RV equals e to the RT, AV. That's not a problem. For example, if you have a matrix 2 here, you can put it in front. That's not a problem. Well, e to the RT is never be 0. That will never be 0. You can cancel it out. So what you get is AV equals RV. I really want to ask you, looks familiar? What is that? Well, you got to remember, we start from eigenvalue, eigenvector. We end with the eigenvector when we talk about the matrix algebra. That V is called the eigenvector in algebra of matrix A, and the R is the associated eigenvalue of A. And alternatively, you can do this way, let me put this way. A minus R, I, you need to take out I, V equals 0. And what you are going to do is find this R and make this as a singular. And then you guarantee you have a solution V, which is not going to be 0, or say it non-trivial, just to remind you a little bit. You understand, if I have a system like this, By equals 0, if the B inverse exists, then you have nothing other than 0. See, you multiply the inverse. 0 times anything is 0. That means trivial. We call it trivial. No interesting. The only way you can make it non-trivial is this B singular. If B is singular, means you need this determinant equals 0. That must be 0. That's how you say singular. What that is, that's a characteristic equation we learned before. That's how you quickly hope you can recall what you learned. So if you find this V, you find the R, what does that mean? That means you solved the problem. Means here's your solution. When you find the R, where you find the R? You find it from here. You find the R from this equation. If the n equals 3, this is a cubic equation. You have 3 R's, maybe repeating. And you get 3 equations, 3 V's. 3V and 3R will give you 3 of those kind of solution. X1, X2, X3, and back to here. That's how you get these 3. See, R1 equal 2, R2 equal -1, R3 equal -1, V1 is here, V2 is here, V3 is here. Those are called eigenvalue. And this is the eigenvector. That's the eigenvalue. And this is the eigenvector, eigenvalue, eigenvector. So we change it into algebraic equation.